Dad, what's the future gonna look like?
What an awesome event this is. It's not very often you get to talk between like a giant robot arm and an eVTOL aircraft, so this is super cool. Let's talk about mining asteroids. I founded this company with a pretty simple dream of living off the planet. And I think throughout humanity, a lot of people have had this dream. The ancient Egyptians have this in their hieroglyphs. We've seen this with the Greeks and the concept of Mount Olympus, all the way through to Copernicus. We've loved this idea of exploring the universe. But there's a big problem with it. It takes a lot of energy to get us off the planet, right? Putting mass into orbit is really, really hard. And so as humans, what we straight up do is try to make it more economical. You guys have probably seen this chart. Elon Musk shows this at every one of his events and says where he's gonna go. And it lays out the cost per kilogram of getting us to orbit from the moon rocket, the Saturn V, which still to this day has launched the largest thing off the planet, which was Skylab, to the workhorse of the industry today, which we fly our missions on. There may be some people in the audience that actually flew on this rocket, the Falcon 9, all the way down to where we can get to with Starship. What you'll notice about this graph, though, is I drew a different line on it. I drew a red one, and that's the floor. No matter what we do, we're not really going to get cheaper than this price point. There is still a cost of energy to get us outside the bounds of Earth's gravity well. So, if we want to live off the planet, we got to figure out what we can utilize in space to make that happen. Now, this is a graph that may look, or a chart that may look very unfamiliar to you. When you were in elementary school, your teachers probably told you about this thing called the asteroid belt, and it was between Mars and Jupiter, and it was this giant belt of asteroids that we knew of the universe. I guess I'm here to tell you a little bit they were just wrong. And this is the actual map of what it looks like today. And what you'll probably notice is there's a ton of little objects right next to the planet. So if you go back to the mid-90s when I was in elementary school, at that point we had discovered 7 asteroids that were near to Earth. Today we're on track to discover 10 million of them. This is a huge kind of eye-opening thing to us, and this comes from the telescopes we bought online. The Rubin telescope, LBTO, have really started to pick up on these objects that are out there. There's almost an unlimited amount of building material we can use. In fact, there's about, I calculated this number the other day, there's 10,000 quadrillion tons of building material as a near-Earth asteroid. That's a lot of material, right? That's a huge amount. So how is it broken down? It's broken down into kind of 3 main types of asteroids. You have your C-type asteroids, or carbonaceous. These are just highly carbon asteroids, right, with some silicates on them. You have the S-type, or stony. These are literally rocks you find in your backyard. They're not that cool, at least not to me. Then you have the one I love, which is the metal asteroid, right? This is the inner core of a planet at some point in the formation of the solar system that was destroyed. It contains high amounts of nickel iron, but it also has something really special. I think something that's especially special to this summit, which is the platinum group metals. It's the highest known concentrations of the platinum group metals. And you may not know what these are when I just name these out, but your iPhone has 5 of the 6 platinum group metals in it. I guarantee you every eVTOL here, every piece of electronics here, platinum group metals are all throughout the summit, and it's a huge problem that we have on Earth. But when we're going to go, I think it's really important to be honest with everybody, because we hear about asteroid mining a lot, and we hear about this concept of being in space. Here's what the economies look like. So the amount of platinum group metals sold in space last year, if you can all guess, was $0. There is currently today no transactional market for in-space resources. So if we want to go mine asteroids, we have to kind of shift the focus back to where a market is. And that market today is on Earth. Last year, $60 billion of the platinum group metals were transacted on, right? That were sold and exchanged through London. It's a massive amount of material. So when I show you this, you probably still think I'm crazy, but hopefully I can convince you I'm not super crazy by the next slide, which is the fact that we have actually mined asteroids before. The Japanese Space Agency sent out Hayabusa 1 and 2. us at NASA sent out a mission called OSIRIS-REx. These missions all went to asteroids, took samples from them, and brought them back to Earth. We really understand the physics of how to go do this, right? Now, we still have the mass problem. So the first problem we set out to solve at AstroForge was that. This is a spacecraft called Europa Clipper. This is the largest spacecraft ever launched outside of the Earth-Moon system into deep space. It was 6 tons, or 2 Cybertrucks. I'm glad I used that metric, seeing as they're all over the place, so you can actually see what they look like when it comes to it. This is the largest thing we've ever lofted on the planet. So if we want to go do this, we have to think smaller. The first thing we did was built Deep Space 2, right? It's a small spacecraft. If anybody hasn't seen it, it's at our booth, 2 hangars over. And you can go see this in actual person, what it's going to launch. It's a 200-kilogram spacecraft, contains 5 kilometers a second of fuel to get us out to the asteroid, and allows us to reach almost every single near-Earth asteroid in existence with this one model of spacecraft. So that's all awesome. Now we got a spacecraft. What do we do with it, right? Once you get to an asteroid, what do you do? Well, we still have to mine it. So this is a little video on how we mine it. Maybe this makes me sound a little crazier, but we mine it using lasers. Obviously, we mine it using space lasers. It's obviously the way you would do this. But we use a directed energy system to remove material from asteroids. And I'm going to show you one real detailed slide that'll highlight it, which is this. This is actually a slide from our scanning electron microscope in the lab that points out the little nodules that we broke off from the asteroid and shows the separation on them. So what you see here is some balls of iron nickel and some balls of the platinum group metal. And why that is important is we can now easily separate them out. Iron nickel is magnetic, platinum group metals are not. This is the simple way we do it to bring it back to Earth. And so when you have a technology like this, obviously the first thing you want to do is make a shitload of money. So here's what it looks like, right? Now, I hope this isn't being broadcast because these are actual contract numbers, so I guess maybe I'll get yelled at later. This is what our next launch is going to cost. It's going to cost $6.5 million to travel into the cosmos, right? Because of the price of Falcon 9, we're going to pay $5 million for our next launch into deep space. That's a total revolution in price point to go access the cosmos, right? To put this all together, that puts our mining margins at about 82% gross margins on mining. To give you guys a sense, the all-in sustaining cost, or the gross margin on Earth, of the best platinum group mine is in South Africa, and it ran at 14% last year. This is a total revolution in how you go mine. So when I tell you this, you should all invest, and I'm just going to walk off the stage, right? Well, it's not really how it works, because I'm kind of leaving out one thing that's super important. I don't know if you guys all saw it on Sunday. I don't know if it's still here. Someone had a P-38 Lightning out there. That's an amazing aircraft. And when you build an amazing aircraft like that, or an eVTOL, or a rocket, what you need to do is you need to test it. You need to test it relentlessly in an easy-to-define environment. And that has been one of the biggest challenges to us is, how do we actually test this, right? I can go in my lab and shoot lasers inside my vacuum chamber and show you cool stuff. Great. That's not really how we're going to go mine at scale, right? This is measured in grams, not tons. We need to think about testing differently. So one of the things we recently did at the company was took a step back and realized something pretty important, which is we live on a giant asteroid. It's called Earth, right? Why don't we go mine this thing? Now, the platinum group metals, the reason we want to go after them on asteroids is mainly because the US does not have them here. That's a problem to us. What we do have in the US, though, is a lot of gold, especially in the better part of the US called the West Coast. That was a shot at Arkansas, sorry. There's actually $3 trillion worth of small gold deposits within the United States that are already found, have already been discovered, that are just too small to economically mine. If anybody's ever been to a gold mine, which I would not recommend going to, they kind of look like this. It's a whole bunch of just massive equipment out there. The average capital cost to start a mine, a small-scale gold mine, is $300 million. That should shock you. It really shocked me until we looked into the equipment cost of doing that. That's just the CapEx. So if you go and find a gold deposit and you go explore it, it's a $100 million gold deposit, probably not a great business model to go spend $300 million to get $100 million, right? That would not be great. But if you remember, I just showed you our spacecraft has to cost $10.5 million. Our refinery is a small fraction of that, right? We can now go access that CapEx. And so, in true startup fashion, I went and bought a gold mine. I actually bought 6 of them. This is one of our engineers in one of our gold mines. It's pretty awesome. And this is the way we're going to now go deploy and test our refinery for the future. So, in short, that's the story of how I get to live my dream of going and exploring the cosmos, and we still get to make a lot of money as we go into the future and pave the way for our exploration of the universe. It is how we get from humans living in caves to humans living among the stars. So, thank you.
The future is gonna be awesome.